Hello and welcome. Today, we're going to talk about the constellation Pyxis. Now, you might not know it by name, but it's much more than just a faint collection of stars. It's really an artifact, a symbol of a massive shift in how we as humans think. Tucked away on the edge of the Milky Way, this quiet pattern of stars actually marks the exact moment when the map of the heavens was redrawn to reflect a new map of the human mind.
You see, our whole investigation today is framed by this fundamental conflict. On one side, you have the sky of the ancient world, a grand stage for gods and monsters, navigated by heroes who literally look to divine will for direction. And on the other side, well, you have the sky of the Enlightenment, seen through the eyes of an astronomer named Nicolas-Louis de Lacaille. To him, the sky wasn't myth. It was a physical space you could measure, you could catalog, and you could understand through the cold, hard precision of scientific instruments. And Pyxis sits right at the crossroads of these two worlds.
So here's our roadmap for today. We're going to tackle the story of Pyxis in 5 parts. First, we'll look at its strange, paradoxical placement among all those ancient myths. Then we'll trace its very modern creation. From there, we'll dive deep into the incredibly violent astrophysics hiding within its borders, and a discovery there that completely reshaped our understanding of how galaxies are even born. And finally, we'll wrap up by looking at the profound philosophical questions that this one little constellation forces us to ask.
All right, let's jump right in. The very name Pyxis throws a wrench in the works. It's named for a mariner's compass, a modern navigational tool. So the immediate question is, how on earth did a compass end up as part of the Argo Navis, the mythical ship of Jason and the Argonauts from ancient Greece?
A mariner's compass on the Argo is, simply put, a glaring anachronism. It's a historical impossibility. The real Argonauts, if they existed, would have navigated by watching bird migrations, following coastlines, reading the stars, not by using a magnetic compass, which wouldn't be invented for centuries. So you have to understand, this isn't some historical mistake. It's a deliberate statement, and we're about to figure out exactly what that statement is. So who's responsible for putting this anachronism in the sky? Let me introduce you to the architect himself, the French astronomer Nicolas-Louis de Lacaille. In the middle of the 18th century, he set up an observatory at the Cape of Good Hope and took on this absolutely monumental task to chart and, more importantly, to rationalize the entire southern sky. The process was very methodical. For thousands of years, this patch of sky was just vaguely known as Malus, the mast of the great ship Argo. Then in 1754, Lacaille, after his own long and difficult sea voyage, formally cut out that section and redefined it. He called it Pyxis Nautica, the mariner's compass. Now, this was actually controversial. The great astronomer John Herschel later argued they should go back to the classical name Malus, but it was too late. Lacaille's scientific instrument had taken root in our celestial maps, and by 1922, its place was made permanent. And this right here reveals Lacaille's real project. He wasn't just filling in some blank spots on a star chart. He was actively creating what we might call an instrumental mythology. Think about it. He created constellations and named them after the telescope, the microscope, the air pump, the essential tools of the Enlightenment. He deliberately placed these symbols of human ingenuity right alongside the gods and heroes of old, as if to say that human intellect was a new and powerful force for navigating the cosmos.
Okay, we've got the history. Now let's pivot, and I mean really pivot, from the history of ideas to the violent physical reality hiding inside Pyxis. Because the most important object in this constellation isn't some bright, majestic star. No, it's a faint, catastrophic, variable system known as T Pyxides. Let's try to visualize what's happening here. You've got a white dwarf. That's the super dense, collapsed core of a star that's already died. And it's locked in a tight orbital dance with a more normal, sun-like star. The white dwarf's gravity is so intense it acts like a stellar vampire, literally sucking a continuous stream of hydrogen gas off of its partner. This gas doesn't just fall straight on. It spirals into a blistering hot flattened whirlpool called an accretion disk, before finally raining down onto the white dwarf's surface. Now, as all that hydrogen piles up, the pressure and temperature at the bottom of the layer skyrocket until they hit a critical point. And then, boom, it ignites in a runaway thermonuclear explosion. The star erupts as what we call a recurrent nova. And you can see the pattern here. It's like a cosmic heartbeat of destruction, with these massive explosions being recorded roughly every 20 years for over a century. And here's the really crucial part, its location.
T Pyxis is only 3,260 light-years away. In galactic terms, that is practically in our backyard. Now, here's the thing. With every single one of those nova explosions, the white dwarf doesn't lose mass, it actually gains a little bit. It's getting heavier and heavier, inching closer to a critical threshold called the Chandrasekhar limit. If it ever crosses that limit, its own gravity will crush it and it will detonate in a full-blown Type A supernova, an explosion so immensely powerful its radiation could actually pose a threat to Earth's atmosphere. So this leads to the terrifying question that keeps astrophysicists up at night. When? When will this relentless process of accretion finally push it over the edge? T Pyxis isn't just some curious object to study from afar. It's a cosmic time bomb, ticking down to a final, spectacular detonation. We are literally watching a supernova in the making. Now, I want you to zoom out with me, way out, from this single ticking star system to the scale of entire galaxies. Because back in 2011, another object located in Pyxis completely shattered our models of the cosmos. I'm talking about the dwarf galaxy Hinais 210. When the data from this galaxy came back, it was, to put it mildly, scientifically shocking. Here you have this tiny little dwarf galaxy, only about 10 billion solar masses in total. But right at its heart is a supermassive black hole clocking in at 3 million solar masses. The proportions are just wrong. It's like finding the heart of a blue whale inside the body of a hummingbird. It made absolutely no sense based on the models we had. You see, this one observation was a direct and powerful refutation of the leading theory at the time, which was called coevolution. That theory basically said that supermassive black holes and their host galaxies grow up together in lockstep. But in Hinais 210, the black hole is way, way too big for its galaxy. It couldn't have grown with the galaxy. It had to have been there first. And this gave rise to a revolutionary new idea, the black hole seed theory. This new model proposes that, in the very early universe, massive black holes could form directly from the collapse of giant clouds of gas. These primordial black holes would then act as gravitational seeds, pulling in all the surrounding matter and triggering the massive bursts of star formation that eventually build an entire galaxy around them. So the black hole isn't the end product of a galaxy's life. It's the very thing that starts it. It's the progenitor. So now we arrive at our synthesis. We've looked at the history, the violent physics, the galaxy-shattering cosmology, all contained within this one constellation. It's time to pull all these threads together into a single philosophical idea about the nature of scientific discovery itself. The meaning of that compass, placed right where the mythical mast of the Argo used to be, is incredibly rich. It's the emblem of Lacaille's instrumental mythology, for sure. It's a symbol of the unchanging direction of human cognition, that relentless drive to know and understand. It represents our ability to find our own way through the unknown, guided not by superstition but by data. And perhaps most powerfully, by replacing the mast, the central structural support of the ship, it makes the bold claim that science itself is the new mast of human civilization. And this really brings us to the final critical point. The ancient sky is full of constellations celebrating heroes and gods, all of whose actions are guided by divine will. Pyxis is radically different. It doesn't celebrate a hero who prayed for guidance. It celebrates the tool that made praying for guidance obsolete. It celebrates the triumph of human reason. So I'll leave you with a final thought to reflect on. Lacaille's project was to etch the greatest instruments of his time onto the fabric of the heavens. If an astronomer were to take on that same project today, what would they choose to immortalize? The Large Hadron Collider? The James Webb Space Telescope? Maybe a representation of a quantum computer? The answer to that question tells us a lot about what we, today, consider to be the masts of our own civilization, the tools we truly trust to navigate the vast unknown oceans of reality.